Hello folks. Today I want to talk through a video I made for one of my colleagues a few months back where we simultaneously show a video of a labeled microscopy image. Here I'm showing little nanometer sized voids in a material that's undergoing radiation, along with some statistics about each of the particles. And you can see I've got them matched up such that the biggest voids are yellow and green. You can see yellow and green here, and I can play this video over time and you can see how they all collectively move together. What I want to show you today is how to make the individual frame of the video and then how to stitch the frames together to form a video that you can then send to your colleague for him to put in PowerPoint. Let's start off with a little bit of preamble. What tools do I need to do this? I'm doing this using matplotlib to create the individual frames, and matplotlib's extension to run ffmpeg, which is a tool that can be installed in a Linux environment. It provides all kinds of functionality for making videos and such. It's a pretty extensive tool, lots of things, but fortunately matplotlib exposes only the parts that you need to make a video. And if your computer isn't Linux and you can't just install it from the command line, it does become available, or it is now available for Windows and OS X via Anaconda. So you can install it that way if it's easier for you. Once you have that installed, you're good to go to make a video. Now, the process to make a video in Matplotlib is to first be able to make a series of or a single frame in the series that you want. And then if you choose to use the so-called func animation tool, which is the one I prefer to, a function which tells you how to update that frame given a position, like given a frame number, alter the frame such that it matches how you need it to be for the animation. The way that mine works is this way. So first we're going to talk through how to make the individual frame. The first important part about this is how I set up a single frame to have 4 different components. Like if we go back to this video, you'll see that I've got 1 big video on the side and then 3 little plots on the left. So the way that I create 4 subframes that are each of different sizes is using the so-called subplot mosaic tool. And I'll expand this so that's a little bit clearer. What I've done is I've given a 3x2 array where I have each of the segments of that 3x2 block marked out by who they belong to. So my first column is entirely image. My second column, has all 3 of the blocks, or all 3 of the plots. Once I do that, I mark the size of the figure and I'm good to go. It generates a tool fig, which allows me to edit figure-wide properties, and a dictionary of different axes which I can manipulate. So once I've got that in hand, I can go through and say grab the image, which as we can see in my map up here is my left column, and I can add my images onto here and perhaps alter the title as I so choose. I can then repeat that process with each of my frames. So here I'm creating a point, or I'm taking the first frame and I'm plotting every void, radius, growth rate, color. I'm doing the same with velocity, and I'm plotting a few chosen tracks. So here's how I create my individual frames. Now, all of this should be very familiar from Matplotlib with one possible difference. You'll note here that I am saving the output of the scatter function, and I'm saving the output of all of my other plots. Because when I'm running that function, I'm going to not create new plots. I'm going to edit existing ones. Let's go down and see how that works. Here's my plot function. It takes the frame number, and what I do is I load in the appropriate frame for my microscopy video, and I edit the existing plots on the chart. You can see here I'm taking IM1, which I know is the plot I originally created to show the grayscale image, and I'm altering its data. You can see setting the data to something different that I had just loaded in from a function that's up at the top of the notebook and out of scope for what we need to talk about today. Same thing for my scatter plots. I've changed something different. Scatter plots have a different, it's not setting data, it's setting the offsets for each of the points. Slightly different, same concept. I'm setting their colors. I'm setting the movement rates. Or, yeah, I guess I'm adjusting the sizes here. Oh yeah, looks like what I'm doing is I'm ensuring all of the points has the same size that I gave it originally. And that's how I create my frame. Now, an important part here, one thing I do just for my own sanity is when this function's called, I actually save the current image just so that I can go through and while this video is rendering, go through and ensure that everything looks the way I expected it to. I don't have to wait what could be 15 minutes for the entire video to render. So at this point, I've created my original frame, and you can see what my frame looks like by opening up one of these PNG files. I can have a function that when I call it will alter the frame. So now I go through and prepare for output. Here I'm calling TightLayout, which adjusts all of the frames to ensure that white space is minimized. And now I pass my figure that I'm going to be editing, my function which edits it, a count of how many frames I'm supposed to be generating. Interval here actually doesn't matter. It's only used if I directly render the output to the notebook or to screen, and I'm turning blit off. Blit, as a brief aside, is an optimization where you can tell matplotlib to only alter the parts of the image that correspond to a list of components that you pass it. For reasons that I still haven't quite figured out, that works for these plots on the right, but not my image series on the left. I don't know why that is. I spent maybe 20 minutes trying to diagnose it before recording this video, and I gave up somewhere in between. So there might be another video. If I have an aha moment, I think I have to use a different kind of animator. Regardless, the only thing that blit does is make the video rendering faster, and at rendering 1 frame per second, it's not slower than my patience. So this is my animation function. Once I have my animation, I call a writer that is able to drive this animation and then save it to disk. You'll note here I've overridden the interval. This is the spacing between frames. If I were displaying this directly from the code as it was being generated, this here is the frames per second in the video file, and I chose a bit rate that's appropriate. I like to use the MP4 format because it works through multiple computers pretty well, and a writer and precision DPI doesn't control the frame rate or the bit rate, it just controls how many pixels are in my image. So here I've taken my animation, I've created a writer, and now I'm calling it animation.save, which is going to drive the animation and write everything to disk. So just to wrap up, we'll show you what that looks like. We're going to restart the kernel. It's going to take a second to get everything ready. Let's hold on. It should pop up a progress bar when it makes it to this point. Yep, we're still cooking. There we are. So now it's going to go through and it's going to render each of these frames, and it is taking about a second each, which is not particularly quick, but I only make one of these videos like once every couple months, so it's not that big of a deal. And because I'm saving the intermediate frames out, I can be sure that at the end of 15 minutes, I'm going to get the video that I want, and if these frames are looking bad, I can stop the process and edit it as I go. So that's how to make a video in matplotlib. Hope this is useful to you. I'll link you to the documentation pages that I read in order to figure out how to do this, and hopefully that'll unlock you to be able to communicate your science, your projects, your work in ways that are more absorbable by others. Hope you're having a good day.